Human intelligence is defined as mental quality that consists of the abilities to learn from experience, adapt to new situations, understand and handle abstract concepts, and use knowledge to manipulate one's environment. Artificial intelligence is the simulation of intelligent behavior in computers. Alan Turing was a mathematician who created a machine to decode the Enigma, which was Germany's secret code during World War II. Alan Turing asserts that specific brain functions can be broken down and rendered in physical terms so that a machine duplicating the behavior will be identified as intelligent. Alan Turing theorized that instructing a machine the way humans are would not get a programmed machine to learn, but would instead require an element of instability injected into an autonomous system, engendering a desire to explore or learn, which is the basis of AI. Turing predicted that rather than try to emulate an adult mind, the best way to develop an intelligent machine would be to emulate the mind of a child and their eagerness to explore their environment, intrinsic motivation. Breaking down the traditional intelligence model into many sub-disciplines brought about many advances in the application of engineering and computer science, such as Deep Blue's chess victory in mid-1997. This led to a change of approach. The previous idea of the computational brain as a single processor changed to an overarching idea that intelligence cannot operate in and of itself. It must be able to interact with or have senses extending into a larger world or reality. Game-playing programs of the 1960s highlighted the sheer magnitude of possible paths that could be followed in order to resolve even the simple problems presented in the game, many of which would be unfruitful. This led to the AI effort of the 60s moving towards heuristically organizing and dealing with path or problem resolution. Universal intelligence was a probability-based theory of inductive inference and predictive AI compiled from both of the theories of computer science and probability. Universal intelligence was predicated on the idea of an entity interacting with its environment. Currently, development of AI applications can involve a variety of methods, but the three most popular techniques are artificial neural networks, fuzzy logic, and genetic algorithms. Artificial neural networks were inspired based on early models of sensory processing in the human brain. These networks apply algorithms that mimic the processes of a human brain, allowing for learning and the solving of complex problems. In the early 1970s, John Holland, the father of genetic algorithms, created genetic algorithms as a way for solving problems based upon the rules followed by nature. Genetic algorithms provide many different solutions to a problem, all of which are based upon the survival of the fittest rule, giving a host of answers that help improve the problem. Fuzzy logic helps to replace traditional logic in situations that are not just black and white. In situations where it is not all or nothing, such as in a car with an automatic braking system, fuzzy logic allows the system to react at a different pace. Instead of getting too close and slamming on the brakes, the car will gradually apply the brakes as it approaches an obstacle. Artificial intelligence can be utilized in many ways today, but technology is evolving quickly and will be much more sophisticated in the future. AI in the future may be able to take over many functions that require humans today, such as policing society, creating complex defense algorithms for security, or even performing medical procedures. Technology plays an integral part in the medical care today. Using AI systems, hospitals can use computers to help track and find patterns in massive amounts of data input, helping to display the data in a way that saves physicians time when dealing with patients. The cyber world is always growing. Along with productive growth, there will always be those who would like to profit from the theft of valuable resources, such as information. Using AI, a company could have a rapid response to any cyber attack upon their network, with the capability for learning from an attack and being able to apply countermeasures according to each perceived threat. Artificial intelligence implemented in many military projects could save immeasurable lives, but also have the potential for disaster. If the government was able to create a machine that could not only track an enemy with no human assistance, which is already possible, but could also take action to remove the threat, this could save the lives of soldiers who would have to go and put their lives at risk to remove the threat. AI, while programmed to complete arduous tasks, may not always complete these tasks in a good way. For example, a car controlled by an AI was programmed to drive you to the airport as quickly as possible. It may travel at double the speed limit or ignore other traffic laws in order to complete the goal. rather than just simply determining the fastest route. In addition to using AI for cyber defense, it can also be reversed and be used for cyber attacks. While an AI could help to defend a system and learn what threats are serious and how to counter them, an AI could do the exact same thing for the attacker, finding flaws, learning what defenses the system has, and how to counter them. If it becomes advanced enough, AI has the potential to break free of the constraints set by the creators of the system and do whatever it wanted. For example, if a weaponized system decided there was a problem with humans, it could wreak untold havoc upon the human population. Furthermore, if an AI system decided humans were a problem, much greater consequences would arise if it reprogrammed every other AI system on the planet to think the same. Since AI runs a lot of society's daily activities, it would not take long for the human population to be subjugated by thinking machines.